We are on page 588. In problem 16, you can see this line over here that we're looking at. Bella names this line LM. Miguel names the line LN. Who is correct? Explain. Okay, so we see right here is LM. It's this part of the line. LN is the entire length of the line. Okay, there is a difference between LM and LN. LM is a line segment. It's a chunk of a line. It's a part of a line. It is not indefinite, okay? LN is the entire part of the line. So Miguel is correct. Because his answer includes or encompasses, his answer is the whole line, not just a part of the line, okay? So Miguel is correct. If we're looking at number 17, construct arguments if all perpendicular lines are also intersecting. Are all intersecting lines also perpendicular? We've talked about this before in the other pages. Remember when we said that intersecting lines, they pass through one point. See how a perpendicular line also passes through one point, but the perpendicular line has to have a right angle, okay? So it has a special requirement. So can a perpendicular line be an intersecting line? No, because it has to have this angle in it. But all perpendicular lines are intersecting lines. So if all perpendicular lines are also intersecting, are all intersecting lines also perpendicular? No, because intersecting lines don't all have 90-degree angles, but all perpendicular lines do. So yes, all perpendicular lines are intersecting, but no, not all intersecting lines are perpendicular because not all intersecting lines meet at a 90-degree angle, like this one. It does not meet at a 90-degree angle. And draw 3 lines. So 2 of the lines are perpendicular, and the third line intersects the perpendicular lines at exactly 1 point. Label the lines with points. I'm going to go ahead and pull out my protractor for this activity. I'm going to start with my perpendicular line. I line these thicker arrows, or these thicker lines in the middle up so they are flush against the line that I drew, so that line meets at a 90-degree angle. I'm going to draw some arrows so everyone knows that these go indefinitely. I'm going to draw my 90-degree box. The last step it asks is the third line intersects the perpendicular lines at exactly 1 point. So if I was going to draw my line through here, oops, it would have 2 lines of intersection. If I was going to draw my line through here, same thing, 2 points of intersection, 2 points of intersection. So I'm going to have to get this line to go right through the middle of these 2 lines, right where these 2 lines meet. Oh, pretty good. Remember, we're looking for precision. Okay, so here you go. There is still only one point of intersection in between all three lines, okay? Label the lines with points. I'm going to label this one A, B, C, D, E, F, and then I'm going to put a middle dot, G, okay? So all the lines have different points on them, just like you see down here in these lines, okay? Higher order thinking. AB is parallel to CD, and CD is perpendicular to EF. If a line through BD, so if we drew a line right here through BD, is perpendicular to AB, you know what? We can draw this so we can actually see it. That would help. We've just got to make sure that this line is lined up flat. Okay. BD is perpendicular to AB, okay? So AB and BD are going to be perpendicular. What is the relationship between BD and EF, okay? Could these lines ever intersect or cross each other? No, they cannot, because they're flowing in the same direction directly next to each other. And we know that lines that will never be able to meet each other are considered parallel. So we can say that BD, line on top, is parallel to EF. Remember, that is a symbol for parallel lines. Okay? Our last question is assessment practice. Which geometric term would you use to describe the power cable shown at the right? Okay, so the cables are going to be these two black lines. So what would the relationship of those two be? Well, do they cross? Do they cross at a 90-degree angle? They don't cross, so they would be considered parallel lines.